Welcome to Maths and Science by IITian channel. I will be continuing with the Maths Olympiad level questions, lectures on them, and I have started from last few classes the algebra. In algebra, let us take a typical logarithmic and exponential equation. To solve it, we have to use the logarithmic properties, and the x and y values are not given here. We have to solve for x and y. The only variables equation is given. There is no constants are given. And the condition is only given is that x and y are positive integers. We have to find out whether we can derive a unique solution for x and y with this equation. We have to solve the equation, and not only solve the equation, we have to prove that this is the only unique solution available. That means it's not only solve and prove uniqueness of solution. By assuming the values of x and y and getting some values of x and y will not work here. We have to prove that it's a unique solution. And what is that unique solution we are going to get? By using the logarithms and your knowledge in algebra. These are all Maths Olympiad level examination questions. Please give attention to the concepts. We are going to clear some good concepts in this question and solve it. And to get the uniqueness, please try to understand the uniqueness of the solution is most important. It's not about assuming some value and getting that value. Why it is unique and why not the other values are not feasible in this particular condition of the equation. That's more important. That's what I am going to explain you. Let's proceed further. What is the question given? It is given that x, y are positive integers and y log x to the base y plus x log y to the base x is equal to xy. Here the bases of the logarithms also different. The base are not same. Log x to the base y, here log y to the base x. This is multiplied by y and the second part is multiplied by x. That is equal to xy. It's a very good example. Let us try to solve it. For solving this, what we require is a very important property of the logarithms. If bases are different, log p to the base q is equal to log p divided by log q. This is the very important property which you are supposed to know. This can also be written as ln p divided by ln q if you take the natural logarithm. By using this property, we will be solving this equation. This is a very important property, we will be using this property. Now, by using this property, what do you say about log x to the base y? That is equal to ln x divided by ln y, and log y to the base x is equal to ln y divided by ln x. With these two we arrived at from the property of log p to the base q is equal to ln p by ln q. Now, what is the given equation? Y into log x to the base y plus x into log y to the base x is equal to xy. That implies replace log x to the base y with ln x by ln y. Y into ln x by ln y. Similarly, you replace log y to the base x as ln y by ln x. Ln y by ln x is equal to xy. That implies let us do the LCM. Let us take LCM. Ln x into ln y is the LCM. Y into ln x into ln x plus x into ln y into ln y is equal to xy. Do you agree? That implies y into ln x whole square plus x into ln y whole square is equal to xy into ln x into ln y. This is a symmetrical equation. You see, symmetry is there. Then, if x is equal to y is replaced with x or x is replaced with y, this equation is not going to change. Hence, y and x are interchangeable, or if we say if x is equal to y, then what happens? Y is replaced by x into ln x whole square plus x into ln x whole square is equal to x into ln x into ln x. Do you agree? 2x into ln x whole square is equal to x square into ln x whole square. Let us cancel both sides ln x whole square, then it implies x square is equal to 2x. That implies x square minus 2x is equal to 0. That is equal to x into x minus 2 is equal to 0. That implies either x is equal to 0 or x is equal to 2. X is equal to 0 is not possible because ln 0 is not defined. As ln 0 is undefined. X is equal to 0 is not a solution. Then second solution is x is equal to is a solution for the above equation provided x is equal to y is equal to 2 due to symmetry, which we have assumed. This is the solution. This is condition for condition x is equal to y, x is equal to y is equal to 2 is a solution. Now, let us consider other cases. Because we have to prove the uniqueness of the solution that x is equal to y is equal to 2. For that, to prove the uniqueness of it, we have to take up the other cases. Here what is given? The equation is y into ln x to the base y plus x into ln y to the base x is equal to xy. Another important property of the logarithms you should know here is ln x to the base y into ln y to the base x is equal to 1. This is one of the important logarithmic properties. We will use that property now. As we have told or considered, let this be P and x into ln y to the base x is equal to Q. Then the equation is reduced to P plus Q is equal to xy means, can we write like this? Y into ln x to the base y into x into ln y to the base x. The multiplication of these two is unity. This implies that is equal to xy, that is equal to this value is P. Y into ln, this value is P, and this value is Q. And this value is P. Can we write this one is equal to PQ? That means ultimately what we have got is that a simple form is P plus Q should be equal to PQ. And when some sum is equal to product, some sum is equal to product, quadratic equation, we can express in the quadratic equation as t square minus P plus QT plus P plus Q, that is equal to 0. The roots of this Then discriminant, we are assuming this, that's all. Small t, don't worry, we have just kept it. We have just took it, that's all. Because from this, p plus q minus pq is equal to 0. We have written in this form. pq we have replaced with p plus q. Sum of the roots of this equation is pq. Product of the roots is equal to p plus q. Product is pq. Sum is p plus q. And we have replaced both of them because pq is equal to p plus q. We have replaced both of them with p plus q. It's a quadratic equation. Then this quadratic equation has the solutions. This quadratic equation after analysis of quadratic equation implies p plus q less than 4. What is the discriminant? Discriminant is equal to b square minus 4ac. b square is p plus q whole square minus 4 into p plus q into 1 just for the sake of simplicity we replaced pq with p plus q because p plus q is equal to pq. P plus q take it as common, p plus q minus 4. When p plus q is less than 4, discriminant is equal to negative. That implies no positive integer solution. If p plus q is equal to 4, first case is less than 4, second case is equal to 4. When p plus q is equal to 4, then xy is equal to pq. pq is equal to p plus q. That has p is equal to q is equal to 2. That implies x is equal to y is equal to 2. That solution exists. Now, if p plus q is greater than 4, we are considering all the possibilities. Discriminant is greater than 0, that implies distinct positive roots for the above equation. We have been told that p plus q is equal to pq. That implies where P is equal to x ln y to the power x into ln what is P value? What we have taken? P is equal to y ln x to the power of base. Y ln x to the base y. Q is equal to x ln y to the base x. These two implies P plus Q is equal to PQ and P and Q are symmetrically tied. What is meant by symmetrically tied? Symmetrically tied means by replacing x with y and y with x, P and Q can be swapped. P and Q can be swapped by replacing x with y and y with x. This implies P should be equal to Q. Swapping can be possible only when P is equal to Q and not otherwise. Hence, P is not equal to Q or x is not equal to y is not possible. Hence, the only possible positive integer solution for x into y into ln x to the base y plus x into ln y to the base x is equal to xy is x is equal to y is equal to 2. With this, I want to conclude my lecture. Thank you for listening to me. Thank you for viewing this lecture. If there is a value addition because of this lecture to you, kindly share and subscribe to my channel. Maths and Science by IITian. Thank you once again. Best of luck.